Alrighty. So, we're going to start out with defining a triangle. Okay, a triangle is a polygon with 3 sides. Okay, we'll look more at other polygons in a later unit, but right now we will stick to, just triangles. Okay, so just 3 sided polygons. We'll then have a whole unit on quadrilaterals, and then after we talk about quadrilaterals, 4-sided polygons will then move into, other polygons and stuff too. Okay. So just draw an example right there of a triangle. Okay, the symbol that we use, okay, it's like a triangle symbol, like a little triangle symbol. So, for example, this triangle here is called triangle ABC. Okay, that's how you'd name it, triangle ABC. That's how we can talk about that object. Okay. The vertices, by the way, vertices is just the plural of vertex. Plural of vertex, right? So the vertices of triangle ABC, okay, are the points, and then what would they be in this case? What are the vertices of triangle ABC? A, B, and C. The points A, B, and C. Okay, the points A, B, and C. Okay, the sides of AB of triangle ABC are what? How would we describe those geometrically? The sides are what, Avery?
AB, AC, and BC.
And what geometric objects are they? Segments. That's right. So the sides are segment AB, segment BC, segment CA. Okay. And then what are the angles of ABC? What could we say here? Name the angles of triangle ABC. Jenny? Okay, angle ACB. So you could use the 3-letter names here. You can also just use the 1-letter name here, because when I talk about angle A, it's very clear there's one angle we're talking about, right? So you could also just use the single letter. So angle A, angle B, angle C, okay? And remember that word vertex, right? We first learned the word vertex when we were talking about angles. The vertex is like the pointy part of the angle, right? And so that's why we also refer to A, B, and C as the vertices, right? Those are the pointy parts, kind of, vertex, right? That's also the pointy part of the angle, right? So that's why we use that word vertex both for like the points on the shape, but also vertex for like the point on the angle. Okay. There's some other vocabulary we're going to use here. So we're going to use the idea of included. Okay, included. Okay, what that means. A side is included by the 2 angles whose vertices are its endpoints. Okay, a side is included by the 2 angles whose vertices are its endpoints. Okay, that's maybe a more complicated way to say what it really is. Okay, so AB, segment AB, okay, is included by what 2 angles here? Or in other words, segment AB is between what 2 angles? A and B, right? So we'll say that segment AB is included by angle A and angle B. Okay, as just an example there. segment AB is included by angle A and angle B. Okay? An angle is included by the two sides of the triangle. I'm just going to draw the symbol for triangle. By the two sides of the triangle that make up the angle. Okay. An angle is included by the two sides of the triangle that make up the angle. So just as an example, okay, angle A is included by, and then what two sides do we say there? Angle A is included by what two sides? Segment AB and segment AC. Okay, so the word included is very similar in scope to what other English word we might use. Between. Okay, between. Okay, really it's between. You can think of it as between kind of there. I know it's maybe, not exactly the same thing, but it's pretty close. Okay. Okay, and then of course opposite. I'm not gonna define what opposite means. I think we all kind of have an understanding here. But we can say, for example, that angle A is opposite. And then what would we say here? What is opposite angle A in our triangle here? What part of our triangle is opposite from angle A? Segment, or you could say a midpoint potentially, but like the entire object here would be segment BC. Segment BC. So angle A is opposite segment BC. Okay, so that's, for example, the angle. And then, of course, you could flip that around and say that segment BC is opposite angle A as well. Let's just do another one here as an example. Let's see. Let's say segment AC is opposite what? So what's opposite from segment AC there? Angle B. Angle B. Yep. Okay, so again, we're just trying to learn our way around the triangle. We're just learning our way around the triangle. Okay? Questions on any of that? Sorry, it's crooked. All good? All right. Next thing we'll look at will be the types of triangles. Okay, so all those things are true for all the triangles, right? But here we got types of triangles. So first of all, we can classify by sides. Okay. So we talked about one relationship already. Jake had mentioned it. What's one way we can classify a triangle by its sides? We could call it what? Equilateral, right? Which is all sides are equal or congruent, whatever word you want to use there. Isosceles, 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 at least two sides are equal. Okay, that might be a slightly different definition than the way you learned it in the past. In the past, you maybe learned isosceles to be only two equal sides, only two equal sides. But with this definition, is an equilateral triangle also considered isosceles? Yes, it would be. Okay, it would be. At least two sides are equal means that if we have three equal sides, the triangle would also be considered isosceles. Okay? And then finally, what's the name for a triangle that has no sides congruent? Jake? Scalene. You got it. Scalene. Can a scalene triangle be isosceles? No, can't, right? Scalene, by definition, no equal sides. Isosceles, at least 2. Can an isosceles triangle be equilateral? Can be, yes, because at least 2 means there could be 3, and so then it would be equal. Okay. All right, so that's by sides. By angles, okay, we could call it an acute triangle. Okay, acute just means all angles are less than what? 90 degrees, right? We already know acute from the past, so I'm just going to put it that way. Use the less than symbol and then 90 degrees. All angles are less than 90 degrees. Okay. We call a triangle a right triangle. It's a right triangle if we have what? One 90-degree angle. So even if the other 2 angles, even if we have two other angles, right, as long as we have one 90-degree angle, we've got a right triangle. Obtuse triangle. How might we define this? One angle over 90 degrees. So I'll use the greater than symbol and then 90 degrees there to make it easy to write. One angle greater than 90 degrees. That's right. And then equiangular. And we already talked with Jake about that. All angles equal. Okay. And if we know our triangle is equiangular, what do we know that all those angles have to be? 60 degrees, right? 60 degrees. Because if we know that the triangle has to add up to 180, and there's 3 equal angles, we can divide by 3, right? And we end up with 60 degrees is our equiangular angle there. Okay? If we know that we have a right triangle, what do we know about the other 2 angles? They're going to have to add up to 90, okay? The other 2 angles will also have to be acute too, right? Because they're going to be less than 90. They have to be less than 90 degrees to add to 180 there. Okay? If we have an obtuse triangle, can we have a right angle in it? So can a triangle be both right and obtuse at the same time? No. Okay? And then also, technically, we could have, but the way that this is defined, if we say if it's acute, but notice the acute here, well, actually, no, with the way it's not defined, it wouldn't work. So acute triangle is right. All angles have to be less than 90 degrees. For a right triangle, you have the one 90-degree angle. The other 2 will be acute, but because one of them is right, we call it a right triangle. Stuff like that. Okay? All right. Last thing here we're going to talk about. So in an isosceles triangle, okay, try and draw one here. Ugh, didn't do a great job here. Okay. What do these tick marks mean right here? They're the same. They're congruent. Okay. So in an isosceles triangle, the congruent sides are called the legs of the isosceles triangle, and the third non-congruent side is called the base. Okay. So in an isosceles triangle, the 2 congruent sides are legs. The third non-congruent side is called the base, even if it's not on the bottom. So if I turn my triangle, it's still isosceles. This thing is still the base. The other 2 congruent sides are called the legs. Okay, so just so you know that. All right. And then that makes these 2 angles right here. Those are called the base angles. Okay. And I think there's a name for that angle, but I'm going to hold off on that one. I think it's called the vertex angle, but I'm not sure. So I'm not sure about that. But there is a name for that top angle there too. And then in right triangles, okay, we also have some names of things too. Okay, so it's a right triangle, make it a right triangle, right angle there. The longest side in a right triangle is called the hypotenuse. Okay, and the other two sides are called the legs. Okay, so the word leg is used in two different kinds of triangles. Okay. I'll go ahead and add in the fact that what we said earlier there, okay, that angles or the acute angles are complementary in a right triangle. Okay, acute angles are complementary. All right. Questions on any of that? So that's our little brief introduction into triangles. All right, that's our brief introduction into triangles. Then what I would like to do now is to go into the book and just talk about a few things, okay, and then we'll get you guys started on your assignment. Okay, so we won't go too far here, but I do want to talk about a few things in the book. So if you would turn to page 313. Okay. We'll also talk about interior angles and exterior angles. Okay. So 313, we already did that little explore that they had us do right there. So we'll jump right down here. Okay. And we'll talk about that rule that we came up with where we thought, hey, maybe all the angles in a triangle have to add up to 180 degrees. All right, and in fact they do. So, since it's a theorem, that means we can prove it. Yeah. All right, but we'll do it together here. I'm not going to make you do it on your own. All right, so here's our setup. Okay, we've got a triangle. Notice we don't know any information about the triangle, but the one little thing you'll notice that we have added in here is this line L. Now, does it look like this is some random line L, or does it look like it's related somehow to our triangle here? Parallel to what? Yes, it is parallel to side AC here. If you read kind of like the previous information up here, so the conjecture about the sum of the interior angles of a triangle can be proven, so it can be stated as a theorem. In the proof, you will add an auxiliary line to the triangle figure. An auxiliary line is a line that is added to a figure to aid in a proof. Okay, and so for step one there, you can see it even in the proof. Draw a line L through point B that's parallel to a line AC, and we're allowed to do that by the parallel postulate. Okay, so you don't have to worry about that for right now. Okay, so we're just given the triangle here. We're not even, which is kind of weird in this proof, we're not even like saying triangle ABC given. We're not starting with the given information. We're just jumping right into the proof. Okay, so since L, I'm going to put that as parallel to AC here, then we can say that the measure of angle 1 will be congruent to what other angle here? Daniel? Angle 4. 1 will be congruent to 4. And so therefore angle 3 will be congruent or equal in measure to 5. Okay. Now, how did we know that the measure of angle 1 will be equal to the measure of angle 4 and the measure of angle 3 will be equal to the measure of angle 5 there? What's the special angle relationship? Jenny? Oh, sorry, I thought you were raising your hand. Madison? Alternate interior angles. Good job. Okay, so here's where I was telling you guys, right, that sometimes just because we move past a unit in geometry doesn't mean we can forget all that stuff, right? Great job, Madison. You remembered that. So yes, alternate interior angles. Okay, you can say alternate interior angle theorem if you want to, or you can also just say alternate interior angles are congruent, something like that, or equal if you want to say that too. I guess we should say equal there. That's maybe more appropriate since we're using measures. Okay, perfect. Now we also know that angle 4 plus angle 2 plus angle 5 are going to add up to 180 degrees because of angle addition and also just the definition of a straight angle, right? 4, 2, and 5 together add up to make that straight line, and so we can add them together to make 180 degrees. But then you'll notice that we take that angle 4, angle 2, angle 5 equals 180, and then we substitute in some other things. So instead of angle 4, what can we substitute in? Angle 1, right? Because they're equal in measure. And then angle 5, what can we substitute in place? 3. Now, why is that significant? Well, 1, 2, and 3 are all angles of our what? Triangle ABC. And we were able to do that by substitution property. And that's the end of our proof. We've just shown that the angle 1, 2, and 3 must add up to 180 degrees. We did not assume anything about our triangle there, whether it was acute, right, obtuse, or equilateral, or scalene, or isosceles. No assumptions. Just based on that information, we were able to prove that guaranteed those angles have to add to 180 degrees. Okay? So we proved it, right? Proved it to be true now for all cases. Questions on any of that? Okay. Okay, so we're going to skip through some of this because this deals with some other, like polygons and stuff like that. So don't worry about polygons. We're going to skip through that. Okay, we're also going to skip through this interior angle stuff too because again, not super important. But continue on to page 317. Okay, continue on to page 317. So now we're going to talk about another theorem called the exterior angle theorem. Okay, so we already know exterior means the what? Outside, right? Outside. So an exterior angle is an angle formed by one side of a polygon and the extension of an adjacent side. So if you look here, all right, bless you. So the exterior angle here is formed by one solid side of the polygon and the extension of this adjacent side. Right, so you extend that adjacent side, and there with your other side of your polygon, and that creates this exterior angle here. Okay. And so then we can also an exterior angle forms a linear pair with the interior angles, right? So this exterior angle together with this interior angle makes a linear pair, right? Two angles that are supplementary that add up to 180. We used that earlier in the warm-up, right? So back in the warm-up. Okay, right, 109, 143, and x were all exterior angles, and then we used the fact that they were linear pairs with the interior angles there to then get their measures. All right, but we also talk about remote interior angles. So if we designate this as an exterior angle, the two remote interior angles are these two angles. Now, why do you think we maybe call these remote interior angles? What does it mean to be remote? What do we think there? What makes them remote? And why isn't this one a remote interior angle? It's an interior angle. Why don't we call it a remote one? What do you want to say there? Emmanuel, you have an idea?
Maybe because like the angle over there is like, I guess because it has like the 180 degree line.
Okay, so this one here, because it's like next to the exterior angle you're saying there, right, it's not remote, right. These two are not next to the exterior angle, they are remote to it. So they are the remote or removed or further away interior angles. So those are the remote interior angles. Okay, so if we, were to go back to our warm-up example, okay, if we're talking about the exterior angle 143 degrees, what are the remote interior angles to the 143 degrees there? So it would be Avery?
The 72-degree angle and angle 1.
Exactly. So if 143 is the exterior angle that we identify there, then the remote interior angles of the triangle would be 72 and y, the furthest away ones. We would not say z, right? X, the exterior angle x, all right, the remote interior to x would be what? So, Luke? Y and z, exactly right. So again, ignore the 72, it's right next to it, it's the other two angles. And then finally for the 109, what are the remote interior angles to the exterior 109 degree angle there? What would be the remote interiors there? Eli? 72 and z. You got it exactly right. Okay? So that's a little bit trickier to see, right? But that's what we're looking for. Okay, so now what we're going to, let's see here. I think all right. So we won't do this activity here. We'll just jump ahead to it. So the exterior angle theorem states this, that the measure of an exterior angle, so like for example here, angle 4, is equal to the sum of the measures of its remote interior angles. So in other words here, the measure of angle 4 should be equal to the sum of what two angles? One and two, the two remote interior. Okay? So let's see here. I think we can fill out this proof and just make sure I don't want to get too ahead of myself here. Yeah. Okay. So we'll try and prove that here right now. Now this is a paragraph proof. We haven't done too many paragraph proofs here, but we'll run through it. It's pretty much the same idea as a 2-column proof. I feel like you've kind of done some paragraph proofs already with the 10 mark stuff, okay, looking at what you've been doing and stuff like that. So anyway, so we're going to have our exterior angle here, angle 4, and then try and prove that 1 and 2 add up to equal 4. Okay, so by the blank, angle 1 plus angle 2 plus angle 3 is equal to 180 degrees. All right, so what theorem allows us to say that the three angles of a triangle add up to 180 degrees? We just saw it, right? Triangle sum theorem. Okay, by the triangle sum theorem, the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is 180 degrees. Also, the measure of angle 3 plus the measure of angle 4 equals blank. What can we put there? 180, right? They're going to be supplementary. 180 degrees because they are supplementary and make a straight angle, right? So we can even use that to help us out. By the substitution property of equality, then, the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to the measure of angle blank plus the measure of angle blank. 3 and 4, right? If 1 plus 2 plus 3 equals 180, but 3 plus 4 also equals 180, then we can set 1 plus 2 plus 3 equal to 3 plus 4. Subtracting the measure of angle 3 from each side of the equation would leave what? So here's our equation. If we took away the measure of angle 3 from both sides, what would be left? Oh my gosh. That's what we're trying to prove, right? There's 1 and there's 2 and it's equal to 4. Okay, we got it. This means that the measure of an exterior angle of a triangle is equal to the sums of the measures of the remote interior angles. Okay, so there it is proved. All right. If this is weird to you, right, if you already don't like proofs and you're like, Mr. Wood, I was barely getting down 2-column proofs. Why are we throwing out these paragraph proofs here? Well, you can see the 2-column proof within the paragraph proof, right? So there's our statement, and there's our reason. Okay, kind of reversed. Statement, reason. Statement, because, reason. Okay, statement, by, reason, right? Statement, reason. All right, so it's all in there. It's all in there. Just sometimes the order gets flipped around. Sometimes they give the statement and then the reason. Sometimes they give the reason and then the statement. But it's all there. It's a sentence at a time. So imagine instead of each, 1, 1, 2, 2, 3, 3, imagine each one of those lines was just a sentence. This is true because this, then this is true because this, then this is true because this, so on and so forth. It's the same idea as a 2-column proof, really. Okay? So let's take a look here at the next page. Are there any other measurements of angles that we can find here in this picture? Volunteers? Madison, what do you say? Can you give us one of the angle measures, or help us find one of the angle measures here?
The angle measure is interior equal.
So this angle measure here, good use of vocabulary. How can we figure that one out? Yeah, so you get that. That's got to be 80 degrees. Good job. Is that the only other angle that we can find in this picture? Jenny?
The angle under 60 is
120. So you said you got this to be 120 degrees because that's equal to, well, how'd you get 120?
60 plus 120 is 80.
Oh, I see what you're saying. You use supplementary angle. So you did 180 degrees minus 60 degrees. I see. How else could we have gotten that exterior angle? By doing what, Brendan?
I was just gonna.
Oh, you're going to give me another angle? Okay, go ahead.
The one above 80 is
100.
100.
Okay, how'd you get that?
I just decided what 80.
Take away from 180. Okay. Madison, you want to say something?
We can also just do 80 plus 40 to get to 120, 60 plus 40 to get to 100.
There you go. Right. So 80 plus 40, the two remote interiors, 80 plus 40 gives you that 120 there too. 100, the two remote interiors are 60 and 40. Emma, did you have your hand raised earlier too? No? Okay. Sorry, I thought I saw. How about for the last exterior angle here? What can we say it's going to be then? You want to go ahead?
Yeah, it's 140.
It is 120. Exactly right. Okay. So again, that can be gotten from subtracting the 40 or adding the 80 and the 60. Okay. So you might be thinking to yourself, Mr. Whitmire, who cares? Did I make a mistake?
Yeah, it's 140.
140. Sorry. Thank you. Yes, that makes more sense. Okay, you might be thinking to yourself, Mr. Meyer, who cares about this stupid exterior angle theorem? If I know the interior angle, I'll just subtract it from 180 and get my answer, right? We didn't need to use the exterior angle theorem for any of those problems. And you're right, but that won't always be the case. For example, let's go down here to how we were going to use exterior angles. Okay, when we start throwing variables in, now you're kind of in trouble. Can you still avoid using the exterior angle theorem in this situation? Yes. It's going to be a little tricky, but you could. Okay. But alternatively, why don't we just use the exterior angle theorem here? If we've got the exterior angle 145, we know that has to equal the 2z plus the 5z minus 2, right? Those are the remote interiors. So you can add them up, set them equal to the 145, solve for z. Okay, z is 21. And once you know that z is 21, you can then plug it back in there to the z there and get that angle B is 103 degrees, for example. Okay. And of course, you could also find angle A too. It would be 42 degrees, right? Just plug the 21 in there for that one. So let's look at letter B here. How could we set up an equation to start solving? We want to find the measure of angle PRS. So how can we set up an equation here to relate our information? What could we do? Will be an equation that we could write. Let's go, Danny, go ahead. Why don't you go?
3x minus 8 degrees, or sorry, yeah.
Yeah, 3x minus 8.
3x minus 8 degrees minus x plus 2 degrees equals 90 degrees.
Okay, so that's one way to do it. 3x minus 8, take away the x plus 2 would equal 90. That's one way to think about it. Okay, I was expecting you to say something more along the lines of 3x minus 8 equals 90 degrees plus the x plus 2. And so but both of those are right. Both of those are right. You would also be able to solve it the other way too. So it's really up to you. Okay, I'm going to go with the second way. Not that your way is wrong, but the second way because I feel like most people would probably have chosen that second way. So, but you're not wrong. And in fact, if you want to do it your first way there to make sure it's right, but it will work. So anyway, subtract x from both sides, you get 2x. I'm going to add the 8 over, so we have 98, but plus 2 equals 100. Divide both sides by 2, we get x is 50. And so our answer is 50 then. No, Mr. Wiz, stop trying to trick us. I want to find that measure of angle PRS. So that's equal to 3 times 50 minus 8. So 150 minus 8, 142 degrees. Okay. Degrees there. All right. Questions on any of that? All right. I would like you to try. Let's have you try number 11. Okay, number 11 there on the next page. Take 2 seconds or a minute or two. All right. If you want to get done number 11 and you want to take a look at number 12, we're going to look at that next too. So I'd like you to look at 12. If you you can't get it, that's okay. But try out 12. Okay? Definitely do 11. Try out 12. See what you come up with there. And then we'll get you started on your assignment. So 11, then 12. We'll get you started on your assignment. Like 30 more seconds here. 30 more seconds. Again, if you get 11 done, start thinking about number 12. Start thinking about number 12, how you might set that up. How you might represent those things algebraically, like x's, expressions, and stuff like that. Stephen, would you tell us how did you set up your equation there for number 11?
I did 63 plus 3x plus 7 equals 5x plus 50.
Great. 63, remote interior, plus 3x plus 7, the other remote interior, equals 5x plus 50. Okay? And then you solve this equation, I'm guessing. So it looks like we have some like terms here. So you can say that's 3x plus 70 equals 5x plus 50. Did you do that?
Yeah.
Okay, and then what'd you do from there?
Oh yeah, I subtracted 3x from 5x.
Okay, so we get 70 equals 2x plus 50.
And then I did 70 minus 50.
Okay, to both sides. So 50 minus both sides there. So you get 2x equals 20. And then?
And then I divided both sides by 2, and I got x equals 10.
X is 10. Okay, is that our final answer?
No.
Nope, we still have to do what?
Substitute it.
Yeah, so 3 times 10 plus 7, because we're trying to find the measure of angle. Whoops, I don't know why I put a line there. And so that equals 37 degrees. And that's our final answer there. Okay, is that what you got? Good job. Good job. Okay. Questions on 11? All right, number 12 then. If the exterior angle drawn measures 150 degrees, and the measure of angle D is twice that of angle E, find the measure of the two remote interior angles. So, do we have a strategy here? All right, let's go to Emma. We haven't heard too much from Emma. So what do you say there? Okay, like that. Aha.
And then set up the equation as 2x plus x equals 150.
Okay, and then solve.
Yeah, and solve, and then you get x equals 50.
Okay.
And then you substitute it for what you made the equation for d to be, which is just 2x, and you get 100. So d is 100.
So yeah, D is 100 and E is 50. Okay, very good. Avery or Madison or Jake, did you guys do it in a different way than that? It's pretty much the same thing. Okay, that's fine. Great job. Okay, measure of angle E, measure of angle D. Okay, good. Well done there. Questions on any of that? You guys understand the logic there? So, D is related to E, right? D we know is twice that of E, so we know some information about letter D, or angle D. We know nothing about angle E. So it's helpful to call angle E x, because it's completely unknown to us. Angle x, or angle E is x degrees. And then since D is twice that of E, we can make it 2x. Okay? Twice that of E would be 2x. And then we can set up our equation from there. Okay, your assignment then, here's what I'm going to give it to you. Starting on page 320. Okay, number 2, and you can skip that one if you're having trouble with it or whatever, that's okay. So number 2, 11 through 15, and 20 and 21. Okay, you have just under 20 minutes left, so there's a good shot you'll be able to get most, if not all of that done. All right, if you use your time wisely there. Don't forget also your 10 marks, right, is due Monday. If you want to try and get it done early and you're not satisfied with your grade, I can absolutely, reassign it before Monday, okay? So let me know if that's the case. Okay. And of course, then Monday we'll be getting a new 10 marks assignment. All right. Tomorrow there's not going to be any set, right? Tomorrow is that shortened block or periods because of the pep rally tomorrow. Okay, so there'll be no set. We shortened classes. I think they'll be like an hour long. So keep that in mind too. Okay. I heard there was one geometry question on the PSAT yesterday,
Yeah, I knew that one.
and I heard you guys heard it wasn't that bad. So
I was like, the only yeah.
there's a lot of algebra too. You said, oh, that's
Sure,
unfortunate.
A lot of people.
at least for the math.
Yes.
Right.
There was some algebra 1 and I didn't have to do that.
Yeah, that's unfortunate.
I got that wrong.
Well, I feel good. You guys were able to use some of your geometry.